Hello everyone, myself Monica and I am a student at Pedagapudi Ramakrishna Siddhartha Engineering College. I would like to thank Emertxe for offering this an amazing internship and I would also thank our project guide Jayalakshmi ma'am. So let us see what are the topics ma'am have covered during the internship. Introduction, C++ programming, IoT interaction, embedded system, home automation project. And our project statement is IoT based automation and using the Blink application and Arduino. And our project is mainly focused on automating different home systems using sensors. It mainly have three functions. These are the functions: control garden lights, temperature system control, water tank control. Let us see controlling of the garden lights. The lights in the garden will automatically turn on when it gets dark and off when there is enough sunlight. It helps us to save energy and provide proper light at night. Temperature system control. The system can automatically turn on or off the system or cool depending on the temperature. For example, if the system goes above 35 degrees centigrade, it automatically switch off the heater and can turn on the cooler. We come to the water tank control. The water tank will automatically control the inlet and outlet valves. When the water level goes below 2000 liters, it turns on the inlet valve to fill the tank, and when it's full, it turns off automatically. In C++ programming, ma'am have discussed these topics. In data types, we have learned float, int, character types. And in looping statements, ma'am have covered single iteration, if, family switch, multiple iteration, do, while loop, those all. In operators, logical assignment, bitwise, territory operators. And in array operators, array and pointers, arrays store multiple values of the same types. We come to pointers, store memory address. And these are all ma'am discussed. What are the challenges of IoT? In IoT, there are five types of challenges. Those are addressing, connectivity, scale, data volume, device size. Let us see addressing. Each IoT device needs a unique IP address. Managing millions of devices is difficult. We come to connectivity. IoT fully depends on internet connection. Poor networks cause data loss or delay. Scalability. As the number of devices grows, handling data and communication becomes harder. Data volume. IoT devices generate huge data which is difficult to store the process. Security. Protecting data from hackers and ensuring privacy is a major concern. Device size. Designing small, low power devices with good performance is a challenge. And this is the architecture of the IoT. IoT has architecture and these have three functions. Those are device connectivity, data processing and analytics and presentation. We come to the device layer. It includes sensors and smart devices that collect real world data. For example, temperature sensor, smart light, smart camera. Gateway layer. It acts as a bridge between device and the cloud, sending data securely. Data processing layer. Cloud serves, store, process, analyze the data to extract useful information. Presentation layer. Displays the proceed data to users through apps. And welcome to the embedded system. Embedded system is a combination of hardware and the software designed to perform a specific task. If the embedded inside a larger system to control its function, it is a larger system. And for example, washing machine has a embedded system to control washing machine. There are types of embedded system: standalone embedded system, real-time embedded system, network embedded system, mobile embedded system. What is standalone embedded system? Take decision on its own. Means semi-automatic. Example is a semi-automatic washing machine. What is real-time embedded system? Real-time embedded system is a task should be completed within a deadline. The task should be completed within a deadline. And the network embedded system. It means that the embedded system is connected to other embedded system. For example, mobile phone, routers, Bluetooth headset. And mobile embedded systems are the portable embedded system. And example are smartwatches and uh, these only not, but there is also another one, that is a hybrid embedded system. It falls under more than one category. Let us see microcontrollers. What is microcontrollers? uh, it is a small computer chips called microcontrollers. What are the main parts of the microcontroller? It has a CPU, memory, RAM, ROM. In memory, we have two types: RAM, ROM, input, output, timers, and counters, serial port communication, power supply. Okay, and in our project, we use softwares like Arduino, PiximLab, Blink IoT. Why we used Arduino? Because it is a integrated development environment. It is a software which is used to write, compile, and upload programs. It uses a simple programming language based on C++. You connect sensors, motors, and other electronic components easily. They helps us to test and control embedded system projects also. And we use Pixem Lab because in online we are doing Pixem Lab. We can't do the hardware, so we are using a simulator, that is Pixem Lab. It is a virtual simulator used to design, test, and debug microcontroller. It is mainly support microcontrollers, but it can also simulate Arduino. And we used Blink IoT. It is an Internet of Things platform that allows to control, monitor hardware devices like Arduino using a mobile or web dashboards.
I am Ingulur Pavitra, a final year EC student at Sri Venkateswara College of Engineering, Tirupati. As a part of our internship with Emertxe technology, we developed a smart home automation system using IoT and embedded systems. Let me now walk through three key slides that highlights the software tools we use, the specific project requirements, and the final project requirements. This slide breaks down the functional requirements of our home automation system in three main domains. One, the garden light control. Based on the sunlight intensity, the system dims or brightens the garden lights automatically. This helps conserve energy and ensure optimal lighting. Temperature regulation. The system monitors ambient temperature. If it exceeds above 35 Celsius, the heater is turned off automatically. User can also remotely switch the heater or cooler on or off by using our Blinken app. And third, the water tank management. The system tracks the water level in the tank. If the volume drops below 2000 liters, the inlet valves is turned on automatically. Both inlet and outlet valves can also control remotely. These requirements reflect real-world needs and demonstrate how IoT can bring intelligence and automation to everyday household life. For the conclusion, in slide 11, the final result of our IoT-based home automation project is a final functional prototype that successfully integrates embedded system with IoT platforms to automate key household street lights. Using Arduino for programming, PiximLab for simulation, and Blinken IoT for remote control access, we develop a system that intelligently manages garden lighting based or sunlight, regulates the temperature by switching heaters and coolers, and monitors water tank level to control inlet and outlet valves. The system responds to the real-time sensor data and allows users to control appliances remotely via smartphone. This project demonstrates how low-cost scalable solutions can enhance energy efficiency, safety, and convenience in a daily life. It also highlights the practical applications of C and C+ programming, microcontroller interface, and IoT architecture. Overall, in slide 11, we can see the results of our project. We can see the temperature of 27.83 Celsius and the water level of 2680 liters. If the temperature is below 30 or above 30, automatically the heater will on. If the water liters is below 2000, the motor automatically on and gives inlet valves and outlet valves. The overall project reflects our ability to design and simulate and implement a smart home automation solution that aligns with modern automation needs and sets the foundation for the future enhancement like voice control and AI generation. Thank you.
Hi everyone, I am Jahnavi, a finally received student at Sri Venkateshwara College of Engineering, Tirupati, and I am very thankful to Emertxe Technologies for giving me this opportunity to participate in the internship, and I really get very good knowledge on Internet of Things. And let me explain the project implementation. And top of this, let me explain the code first, right? Here you can see the Arduino file here, and there are so many files are attached to this ION INO file, which consists these many files within this INO file. And here we are using three modules, that is LDR and serial tank and temperature system. And each module consists of two files, that is .h file and cpp file. .h file is actually contains the pin numbers of the uh, sensors and the following, and the .cpp file contains the mm, functions which we are going to implement in the Pixim lab as per the requirements. And let us start the explanation from the LDR sensor. And here we are defining the LDR sensor as a A1, and garden light, that means LED, as a 3. And here you can see we have defined it as 3, pin number 3 for the LED, and A1 to the LDR sensor. And here we are calling a brightness control function here in the init function. That means we are creating a function, and in this function we are calling the brightness control function, which is already defined here in the .cpp file. Let us see this one. Right here we are defining a function. In this function we are defining the garden light as the output, right? Next, we have defined unsigned integer, two unsigned integers, that is light intensity and duty. Let us see where we use this thing. Okay, next, we are defining another function to control the brightness of the LED, that is brightness control, right? Now, the variable which we have defined before, that is light intensity. In this light intensity, we are reading the LDR sensor value. That means the intensity of the LDR we are reading in this light intensity. And here in this duty, we are scaling the light intensity from 1 to 1023 and 255 to 0, right? Here in the analog, right, we are going to control the LED, that means green light, what we have defined. We are going to control the LED as per the duty, that means as per the scaling, right? Okay, now let us go through the system temperature system. And here we are defining pin numbers like 4 and 5 to the heater and cooler. For the heater, we have given 4, and cooler we have defined pin number 5. And for the temperature sensor, it is we have defined A naught. And here we are defining the functions, right? Let's see where we are using these functions, right? Let's see the .cpp file. And here in this file, we have created a function called init temperature system, where we are defining heater and cooler as output, like a heater pin and cooler pin as the output. And we have defined another function called read temperature to read the temperature, that means the current temperature, which is following by using the sensors, right? We are getting the current temperature using this formula, and we are returning the temperature in values using a return function, like we are returning the temperature value here, and this is comes in float format. Okay, and next we are defining a function called cooler control. In this cooler control function, we are defining another variable called control, and this control is in bool format. That means it will get only in 0 and 1. If the control is 1, then this if block will be executed. That means the cooler will be on, and if it is not pressed or it is 0, then this function going to be executed, the cooler going to be off, and here the cooler will going to be on. Right, next coming to the heater control function. Here also we have defined a variable called control in bool format, that is 0 or 1. If it is 1, then the heater will be on. That means if it's pressed, then the heater will be on, and if it is uh, turns off, that means if it is not pressed, then it will go the heater will be off, the heater goes off. And coming to the serial.h, this serial.h, we have defined the macros, like macros inlet valve, outlet valve, high float, low float, volume, and to enable the water uh, into the cereal tank, and disable to goes of the water to the cereal tank or from the cereal tank, right? Next we have defined the functions, these functions. Let us see these functions and how these functions are going to be work, right? Let us see the .cpp file. Here in the serial tank.cpp, we have defined a function init serial tank. In this function, let's see this line. In this line, we have defined the serial communication with the serial communication of the Arduino with the um, se- uh, serial tank, right? And next, we have written the same code in the 3 lines to sync the serial communication with the sensor. That means with the serial tank. And next, we have defined a function volume to read the current volume of the water. And here, uh, right here it reads the this line reads the current volume of the water. And here you can see we have defined value h and value l. This resembles to the high value and the low value of the serial tank, right? And this line volume tank resembles to the current value of the uh, current volume of the tank, and we are returning the value here in the end of the function. We have defined a function enable inlet. we have defined this function to enable the inlet. That means we are going to enable this inlet valve that allows the water into the cereal tank. And we have defined another function, disable inlet. That means the inlet valve going to be off. This function enables, that means this allows to supply the water into the cereal tank, and this will off the supply. That means it will goes off. And next we have defined another function called enable outlet. That means this valve, this enable this outlet valve going to be on. That means it will open and the water supply will be goes off, goes down. And here in the disable outlet, that means the water supply will be off here. Okay. um, Next, let us see the main code. We have defined three macros, right? Blink template id, blink template name, blink authentication token, right? Let us see why we have created these macros. Let me explain this one. For this, first we have to open a blink console, and here I have created a project template called home automation, and here I have defined a device called Arduino, and I have set up the data stream, and I have added the device Arduino from here. Let me explain the data streams what we have included here. We have included a heater, a temperature, cooler, volume, inlet valve, and outlet valve. In the Blink app, we are going to use this heater as heater pin, heater switch, and this as cooler switch, this temperature as temperature gauge, and the volume as volume gauge, inlet as switch, and outlet valve as also as switch. Right? Let's go to the code. And here we have included this template id and authentication, the template name and template id, and also the password for this home automation project. We have included these all in this code, right? Next, we have included these three libraries for the blink app control. And next, these two libraries are included, y.h and crystal liquid crystal I2C are included too for the CLCD. And next we have included the .h files what we have created earlier, right? And next we have created four bool variables. And next we have created an object called timer to read the temperature on the blink app at a particular time. And next we have set the LCD address as a 16 into 2. And next here we have defined a function, blink right function for the cooler pin. That means here in the above we have created a bool variable cooler switch, right? In there it reads the parameter as int. It is a parameter as int. It is also an inbuilt function where it reads the change value of the pin. And we are calling the cooler function which we have created in the .cpp file of the uh, system temperature system. And if the cooler switch is 1 or it is pressed, I mean it is to be on, then the LCD the LCD going to be print cooler on at a position of 8 comma 0 in the LCD, right? If the cooler switch is 0, that means it is in off mode, then the LCD going to be displays the cooler off at the position of 8 comma 0 in the LCD. Find another function called heater VPin. That means earlier we have created a bool variable called heater switch, right? Now we are reading the um, changed value of the pin here in the heater switch, and now we are calling the heater control function which is going to read the bool value. And next, if this heater pin is true, that means if it is on, then in the LCD it displays heater is on, that means HDR on at a position of 8 comma 0 on the LCD. Okay, next, if else if the heater switch is 0, or it is off, then it displays heater off in the LCD at position 8 comma 0. Next, we have defined another function for inlet pin, VPin, right? Here also we have defined we have already created a variable inlet switch, right? There also we are reading this reading the value, current value. And next, if the inlet switch is on, then we are calling here enable inlet, then the water will be comes inside the tank, cereal tank, right? And it displays inflow on at position 7 comma 1 in the LCD. And if it is off, if the inlet switch is off, if we make the switch off, then the disable inlet function going to be implemented, and LCD dot print that means in LCD inflow of will be displays at a position 7 comma 1. And next we have created another function for outlet VPin. That means in the outlet switch the bool variable what we have defined, as same it reads the value, and if the outlet switch is on, then enable outlet, then the uh, this particular thing will be on, then the water goes down, and in the LCD outlet flow on, that means this is going to be displayed at position 7 comma 1. Else if it is off, then disable outlet function will be going to be implemented, that means this is going to be off, right? And it displays outlet flow off at position 7 comma 1, right? And next we have created an function called update temperature reading to display temperature and volume as water gauge on the Blink app. In the Blink app, um, this function send the current temperature to the Blink mobile, and here it will send the current volume of the cereal tank to the Blink app, right? Next we have created another function called handle tip, because in the requirements it is given that the if the temperature rises above 35 degrees centigrade, then the heater goes off automatically, right? So we have defined this function for that requirement. Here, if the current temperature is above 35 degree, that means 35, and heater switch should be on. If heater is on and the temperature is above 35, then this if block going to be executed, right? If it happen, then automatically the heater switch goes off and heater control, this function going to be executed, and in this function the heater goes off, and in the virtual right, that means in the blink app also, the switch might be on in on mode, right? Then that switch also goes off by writing this line. And for printing the notification, we are writing that heater off at position 8 comma 0, right? In the same way, we have created another function handle tank to handle the tank control, to control the volume of the tank, right? The requirement is if the volume of the water is less than 2000 and the inlet switch is off, then we have to make the inlet valve to on, right? That's why we have wrote an if block. In the if statement, we have given if the current volume is less than 2000 and the inlet switch is off, then this block going to be execute, right? Then automatically the inlet switch goes on. We are enabling the inlet valve through this function. And in the virtual, right, that means in our mobile app also, the inlet v pin, that means the inlet valve pin goes on automatically. And in the LCD, that means to print the notification, uh, it prints inlet inflow as on at position 7 comma 1. And and this is the another condition, if the volume of the water is greater than or equals to 3000, that why we have mentioned 3000 means the maximum value of the cereal tank is 3000. That's why we have mentioned here 3000. If the volume of the water is greater than or equals to 3000 and inlet valve, I mean inlet switch is on, then uh, it results the waste of water, right? That means we are turning off the inlet switch here and disabling by using the disable inlet function. And as same in the blink mobile app, the automatically inlet valve pin goes off and it prints a notification inflow of at position 7 comma 1 in the CLCD. And coming to the void setup, we are initializing all the blocks what we have created earlier. We are initializing the LDR function, init LDR, and init temperature system. Here you can see, let me show this one. Here we have initialized this one, right, as output. Here garden light as output. So we are initializing every output here in the void setup. We are initializing the LDR sensors output and we are initializing the temperature systems output. And here blink begin. That means the blink app going to be worked from this particular from this function. And next we are initializing the CLCD. Here we are we are set the cursor at 0 comma 0 position and we have printed this home automation for a period of time, that means for a 1 second, and then the LCD goes clear, that means LCD will comes as a clear screen. And next we have initialized the serial tank outputs here. And next we have created a we have defined a function for updating the temperature for every 1 second, because it cannot read the 10 values at a time, right? That's why we have defined this function here. And next, coming to the while loop, um, we have write all the functions what we had what we have defined in the cpp file. Not all functions, the required functions for uh, controlling the brightness of the led. We have defined a brightness control function, right? We are calling this function here, and we are to execute the blink app. We are defined the blink.run. For the current time, we are using timer.run. And here, to read the temperature from temperature sensor, we are defining temp here, temp, and we are reading the current temperature. And also, uh, if the temperature goes more than 35, so we have to handle the temperature, right? So we are calling the handle temperature, and we are calling the handle tank to control the tank volume. And we are reading the volume of the water with this line, and we are displaying the volume of the water and displaying the temperature on the CLCD. And this is the code version or coding part. My teammate Pavitra will lead the next project implementation part. Thank you.
Now let us dump the code. That means I have already dumped the code. So let me reset this. Yeah, now the code is executing. Here we can see, let me explain how the first earlier. If the sunlight is high, the intensity is light is slow. The sunlight is disappearing, the light increasing its brightness, right? If there is no presence of light, now see the LED brightness, it gives the 100% brightness, right? Now let us see the temperature system working. See now, let me on the heat. This is the first heater first. See here, it presents heater on. See, the temperature is changing, right? We have written function called handle temperature, which is called handle temp. Did you remember? Now the heater goes off automatically because we have written a function, the function which is called handle temp, to cut off the heater when it reaches 35 degrees centigrade, right? The result of this, now let me on the cooler. See, the cooler is working, the temperature is decreasing, right? Let me off it for a while. see it shows cooler off. The cooler is off. Now let us work with this one, right? Now let me on the outlet. Outlet because it is 100% filled, right? Let's wait. When it goes or reaches 1000 liters, it automatically, the inlet automatically on. The inlet automatically on by itself. Because we write the code like let me off inlet, we see inlet is filling. Now you can see the progress here also, right? Let us wait until it reaches 3000 liters. Now the outlet is automatically off. Then the inlet is also goes off. And this is the project. Thank you.